Okay, for our second example here, we're going to go on to number 3. I think you'll find number 2 is pretty similar to number 1, so you don't really need an example for it. So for number 3, I went ahead and graphed it. You're just going to type that into y equals, and you're going to get 0 and y2 and do second trace intersect. So what you get for your answer, I only see this one intersection here, okay? Now again, we have 3 as the highest power. So what we need to do is we need to find, we have one intersection, we already found that, it's at 2. So we know that there are going to be 3 roots, and we're only seeing 1, so we know the other 2 are going to be imaginary. So this is the first time that we really get somewhat of a challenging problem. So what I'm going to do here is I'm going to go ahead and put x equals 2. I'm writing in Paint, so it's pretty rough. Oh, that's such neatness, wow. Okay, so we get x equals 2, and we're going to go ahead and divide this. You can do long division if you'd like to. I'm just going to do, oh boy, I'm just going to do synthetic division here. Alright, I do need to type this out. Okay. So we're going to go 5, negative 9, 4, and negative 12. And I'm just going to multiply, I'm just going to do division. So first, I drop down this first number, always, just drop down that first number. Then you take it, multiply by what's in the box. I get 5 times 2 is 10. And I'm going to add it to the number above it. So negative 9 plus 10 is 1. Then I take this number, multiply it by what's in the box. I get 2. 4 and 2 is 6. I take this number, multiply it by what's in the box, and I get 12, and I get 0, which is a good thing, because if my remainder is 0, as it is here, that means this is a root, which we already knew. And if we didn't get 0, that would mean we made a mistake. So now we have these numbers, 5, 1, and 6. We can go ahead and write our equation. It's going to be 5x squared, I'm going to write it like this, plus 1x, or just x, plus 6, with a remainder of 0. Okay, so now we have a quadratic, and we know that answers are going to be imaginary. So what we have to do is we have to take the quadratic formula and apply it to this equation, and then we'll have our imaginary answers. So I know the quadratic formula. I'm going to do this in pencil. It'll be rough, but you'll be alright. Negative b, which is 1, is b, so negative 1, plus or minus the square root of b squared, which is 1 squared. I know 1 squared is 1 because math. Then minus 4 times a times c. A is 5, c is 6. So minus 4 times a, 4 times 5 is 20, times c. 6 is 120. 4 times 5 times 6 gives us that beautiful 120. All over 2 times a. 2 times 5 is 10. Okay, so we're going to get this is equal to negative 1 plus or minus the square root of negative 119 all over 2a, which again is 10. Okay, 119 I believe is prime. If you weren't sure about that, you could just try different things. 3 doesn't go into it. 5 doesn't. 7 doesn't. No, 7 does, doesn't it? Let's see. Yeah, 7 does go into it. 7 goes into 11 one time, and it goes into 9, and it goes into 49 7 times. So it'll be 17 times 7. But now these are prime, so we're okay. So I won't get any pairs when I break it down. So all I have to do is take out this negative. I know the square root of a negative is I, so my answer here is going to be -1 plus or minus I root 119. I feel like that's I wrote root 119. Okay, root 119 all over 10. It's so pretty. And my other answer is 2. So my three roots are 2, -1 plus I, root 119 all over 10, and -1 minus I, root 119 over 10. Cool.